Hello, today we're going to be looking at the AnoleX 3020 Evo CNC. Many of you may be familiar with the 3080 tabletop CNC machines, but this Evo model is a huge improvement. We have linear rails on the X&Z and rods on the Y-axis. It's hard to express just what an upgrade in rigidity you get from linear rails, making the CNC far more practical and letting you get more out of your spindle. Throughout this video I'll be using the painter's tape method for holding most of my work. Here we just apply painter's tape to the bed and to the bottom of the workpiece. Then apply CA glue and a catalyst to hold the work down and avoid the risk of running into clamp fixtures by mistake. For my end mill I'll be using an O-flute bit. These are single flute cutters with geometry designed to extract the material by forcing it through the O shape running through the centre of the end mill. The only downside is the fewer flutes, the less steel you have behind the cut. This is not going to be a huge issue on a tabletop CNC, and the flexibility to cut a whole range of materials makes it an excellent end mill to get started with. First I decided to cut some MDF. As the name implies, this is medium density, so it gives you a good starting point where you want to be with common softer woods like cedar, pine, spruce, fir or redwood, and where you may want to slow down or take shallower passes for harder woods like poplar, cherry, maple, oak and the king of woods, walnut. So I cut a bunch of pockets ranging from 2 to 5 mm in depth and a feed rate from 200 to 500 mm a minute. With the stock 300 watt spindle I was expecting the sweet spot to be around 300 mm per minute and about 4 mm depth of cut. But to my surprise the spindle didn't start getting bogged down until 500 mm a min at 5 mm depth. But this is really going to depend on the quality and type of end mill that you're using, so for all the settings I show here I would consider a good starting recipe to build on. Not at all the limit of the machine itself, as tooling really matters. First thing I wanted to make was a holder for my end mills. So I jumped into Fusion and laid out some simple pockets and bore holes using adaptive clearing. For my starter MDF recipe I went with 300 mm a minute feed rate and a depth of cut of 3 mm. Again, this is a starter recommendation as I was able to hog out a lot more material, but as it was a review unit I felt much more comfortable pushing it to the limits, since I was using good quality tooling and not just the cheapest bits from Amazon. So I recommend starting here and working your way up. For boring you can be quite aggressive with the O-flute as it's so good at clearing material. Here I went with 400 mm a minute, but with a relatively shallow 3-degree ramp. After cutting the pockets I found they were dimensionally correct but a little on the tight side. It was very easy to set a contour cut and expand them by an extra 0.5 mm on each side for a much better fit. And I ended up with a very handy tray for my 3.175mm tooling. All done without a tool change and only 3 operations: adaptive clear, bore and a contour cut. Next I moved on to a simple spoil board design with counterbore holes for mounting to the bed and 6mm holes for bolts to screw into insert nuts mounted at the underside of the spoil board to give me some flexibility for clamping and jigs. You may also notice I'm using a 3D printed end mill fan to clear the dust, as actually fitting a dust extractor makes for a clean workshop but a pretty poor video. After milling out the spoil board and fixing it to the bed, it's time to surface the bed so it's tram with the spindle. Here I use a 1-inch surfacing bit that is just large enough to surface parts of the board that are just outside the limit of the end stops. I like to take 0.2mm passes, and after the first pass I'll take a pencil and scribble all over the spoil board so I can see when all the pencil has been removed I know that the bed is flat. Once level, I added a grid with an engraver bit just to help with aligning the workpieces. Next I did some test cuts on 3mm acrylic. And it was easy to cut through with 2 or even 1 single pass. But if you look at the chips, you'll see that they're a bit flaky and inconsistent in size. What you really want to see with an O-flute bit is plastic in consistent chips, almost like grains of rice. And here you can see with 3 shallow but faster passes we get really nice chips, all the same size, extracting out of the cut, stopping them from being recut and the risk of melting the acrylic, and having it stick to the bit, rather than here where most of the heat from friction is being taken out via the chips for a much cleaner cut. Next we move on to aluminium, and here the linear rails really shine. I started with a simple engrave as a test cut and achieved really good results. I've gone on to change the recipe to go a little deeper than I did here, and I've had no issues. Next I wanted to try cutting slots. This cuts by ramping into the work at a fixed degree rather than plunging and making a linear cut, so the load on the bit slowly increases as the cut progresses rather than fully loading it from the whole cut. As a result, the feed rate is less relevant than the ramp feed rate, as the whole cut is a ramp. Here it's set to 300mm a minute. And had no issue cutting through and leaving a really clean cut. As this operation only uses the X and the Z-axis, that are rails rather than rods like the Y, I went for a wider slot to engage all axes and see if there was any issue with Y. I was really happy to find yet another really clean cut, dimensionally accurate with no visible issues or inconsistencies. Next I moved on to some adaptive clearing and manually adjusted the settings on the fly and came up with a pocketing recipe, again going a little shallow but with a faster speed. I've got to say I think this is very impressive for a 300-watt spindle and no finishing passes. Finally I went with similar settings to try a contour cut. I would personally never advise making a cut like this. It's far safer to flip the workpiece over and cut through into the spoil board rather than having a dangling obstruction, especially if you don't know for sure that you have clearance for the part to fall clear of the tool. So do as I say, not as I do in this case. Next we moved on to PCBs, where I think this machine really shines when it comes to value for money. Looking at the price of dedicated PCB milling options from the likes of Bantam or Other Mill. And PCB milling really deserves a video of its own, so I won't go too much into the process here. But if you want to see a dedicated step-by-step video for PCBs, just comment below. But that said, my workflow is jumping into KiCad, laying out the PCB, then loading the Gerber files into FlatCam, where I can make CNC files for the edge cut, the drilling and the PCB. Once we have those files, we can go into our G-code center. Here I'm using Candle, and it's key that we get a height map for our PCB. It may look flat, but we are dealing with depths of cut that are 0.05mm here, so a small difference in height on the board can make a huge impact on the consistency of our cuts. Here I opted for a V-cut bit with a 0.2mm tip and a 30° angle, which is pretty standard for PCB isolation routing. And here I would really recommend spending a little more money over the cheaper ones that I found are often ground off center, so they end up giving you uneven cuts. And we are already dealing with such tight tolerances, bit quality makes a huge difference. I'm doing isolation routing here, so I'm cleaning just the copper around the traces and the pads and leaving the excess, making for much quicker prototyping. When it comes to drilling, you can be quite aggressive with your Z speeds. Though keep it in mind you might want to slow down a little for really fine drill bits, below 0.8mm, which is probably the most common size that you'll be using. For cutting out the board itself, I opted for a single flute upcut bit over the corn bit that you often see a lot of people using. I'm not a fan of the corn bit for two reasons. First, inconsistency in the diameter, and more importantly, health risk. PCBs tend to be made out of fiberglass or phenolic paper, and frankly you don't want to be breathing in either of those in dust particles. A corn bit will make a very fine dusty mess rather than a slightly denser chip that you'll get from a single flute cutter, sending much less dust airborne. Even so, you should ideally be using dust extraction and a well ventilated space. Once we get the PCB under the microscope, we can really appreciate just how clean and uniform the traces are. And this is mainly down to the linear rails on the Z-axis, helping the spindle stay rigid. A huge pro to this machine over its counterparts still using rods for Z-travel. And here we can get an appreciation for how fine a tracks we can get, with a thickness of 0.4mm, without any tuning, just using this starter recipe and a quality V-bit. So what are my final thoughts on this machine? First, I really appreciate AnoleX for letting me test the machine for a couple of months before making the video, so I could give an informed opinion rather than just first impressions. Not a lot of companies have that kind of confidence in their product, along with an appreciation of what is actually involved in filming a review. So how is the 3020 Evo? First, it may look like a 3018, but the performance is far superior and the increase in price very much justifiable. The 3020 Evo is a legitimate tool for the workshop, not just a cheap platform for learning basic CAD and CAM. I'm so glad they went with rails on the Z, unlike many offerings in the same price range from competitors. Whether you're just looking to learn CAD or CAM and want a machine that is capable enough to keep up with you as you progress, or if you want a reliable tool in the workshop for cutting and engraving wood, plastics and light aluminium and brass duties, this is a really good option. For me, I feel the stock setup really shines for PCB fabrication. But the story doesn't end here. If you're interested in seeing what this tabletop CNC can do with a 1 horsepower Makita trim router, hit the subscribe button. I hope you found this review useful, and any questions just post in the comments below. Thank you for watching.